Let's take a look at an application. When a bee forages for nectar in a patch of flowers, it gains energy. Suppose the amount of energy, calories gained, during a foraging time span t is measured in minutes and is modeled by the function f of t equals e times t over k plus t, where both e and k are positive constants. So the function we have here represents the energy gained. So energy gained is modeled by this function we have been given. And now we're being asked to find the rate of energy gain while foraging in the flower patch. So rate of energy gain is referring to a rate of change in f of t, of change for f of t. And so that means what we're interested in is what is f prime of t, because the derivative represents the rate of change in a function. So let's go ahead and take a look at what the derivative of this particular function is. Now, as we go about doing that, first we notice that this function presents as a fraction. So I will be using the quotient rule to take its derivative. Another thing to keep in mind as we take this derivative, that we are to treat e and k as though they were constants. So when I go to take a derivative where the key e or the k is concerned, I would treat them in a manner similar to as I would say the number 3. Okay? So let's go ahead and see what this would look like. So f prime of t, we're going to use the quotient rule, is the derivative with respect to t of our numerator, e times t, times our denominator, minus the derivative of our denominator, so the derivative with respect to t of k plus t, times our numerator, which was e times t, all over our denominator squared. So k plus t squared. All right, so let's go ahead and work this out. So looking at the derivative of e times t, well, e is a constant, so it will be e times the derivative of t. And so e times the derivative of t would be e times 1 times k plus t minus, and now the derivative of k plus t. Well, remember that k is a constant, so the derivative of k is going to be 0, plus the derivative of t, which is 1. Now that's multiplied times our numerator, which was e times t, all over the quantity k plus t squared. All right, so multiplying out a few things in our numerator, I'll have e times k and then plus e times t. So we'll have ek plus et minus et all over k plus t squared. Now, simplifying things up a little bit, I've got a plus et and a minus et, so those will sum to 0. And so my derivative ends up being f prime of t equals e times k over k plus t squared. And as this is an application problem where there are units associated with quantities, we do want to include units in our answer. So recall that our function f of t represented energy gained over time, then that energy is measured in calories. So our units here would be something like calories per unit of time, and our unit of time was given to us in minutes, so calories per minute. So our derivative here, f prime of t, represents the calories gained per minute of a bee foraging in a patch of flowers. I hope this helps.